Bom dia a todos. Eu sou Daniel Fermucasai, sou engenheiro aqui da Itaipu Binacional e estou tendo a honra de introduzir, mediar esse encontro do Água em Pauta, uma iniciativa da Associação Brasileira de Recursos Hídricos, a BR-Hidro, uma tradicional iniciativa. E essa edição do Água em Pauta é muito especial porque está ligado ao evento, a terceira edição do South America Water from Space, que vai ocorrer aqui em novembro, na Itaipu Nacional, dos dias 21 a 25. Então, hoje a gente conta com a presença do Jean-Francois Cretaux, que ele é o líder científico da missão SWOT, missão que vai ser lançada em dezembro de 2022. E esse lançamento do SWOT está muito ligado, vai ser muito discutido no âmbito do evento aqui em Itaipu. Então aqui com a gente o Jean-Francois Cretaux, também o Daniel Moreira, do Serviço Geológico do Brasil, que vai estar como debatedor, e o Fabrice Papá, do IRD, da França, que também vai estar como debatedor. So I will pass the word to Jean-Francois Cretaux to present a little bit, to talk to us about the SWOT mission. And thank you very much for joining us today, Jean-Francois.
Okay, thank you. I will share my screen, just a second. Voilà. You see it clearly?
Yes, Jean-Francois.
Oh, okay, I can start. So, just a second. So, I start. So I will present you the SWOT mission for hydrology. So SWOT is a mission which is a satellite for both oceanography and hydrology. So we have PI for oceanography, we have PI for hydrology. I'm the PI for hydrology. So I'm going to talk about hydrology. And I'm going to try to show how SWOT will change our vision of continental waters. So just a second. So my presentation will be will present some different things. The role of continental water on the global water cycle, which is one of the reasons why we have set up this SWOT mission. I will show you why SWOT is a technological challenge, and give an overview of SWOT expectation in hydrology based on recent results done on with the science team. And also I will finish with some words on the Calvary. Calvary is a very important topic for such satellites. So I'm Jean-Francois Cretaux. I work for CNES in France and in the laboratory, which is the Lagos. SWOT mission is a cooperation between CNES, between NASA, between Canadian Space Agency and UK Space Agency, but mainly between CNES and NASA. It's always the same problem trying to move on to the next slide. Okay. So first, some words on the water cycle study. What is the water cycle? It is shown in these figures, in this image on the left. The water cycle is simply the transfer of water between the ocean, between the atmosphere, and between the continent. Water is evaporate, water is precipitate, and water is stored, and water is also running along the river. So we have different components in the water cycle. We have the snow, we have the glaciers, we have the vegetation, ocean, etc., and we have lakes and rivers. And the water cycle can be simplified in this equation. It's a trivial equation which shows that we make the balance between what is inflowing to the system and what is outflowing. And in this equation, several terms. So we have the snow cover, we have the soil moisture, we have the underground water, we have the precipitation, evapotranspiration, and we have also the water stored in lakes, which is written in blue, and the water which is from the land to the ocean through the rivers, which is called, represented here by Q, which is the river discharge. And it is written in blue because this is the two main components for which we will have new information using SWOT. So actually, calculating water storage in lakes can be done for big lakes, for some lakes, using combination of satellite altimetry, for example, and satellite imagery. River discharge can be estimated also more or less using models and assimilation of altimetry data in models, etc. But clearly, SWOT will be dedicated to determine directly these two variables, these two components of the water cycle. The other component of the water cycle, you have already some satellite mission designed to calculate them: thermal infrared, GPM for precipitation, SMOS for soil moisture, satellite imagery, and GRACE for the total water storage change. So that's the main topic of SWOT, which is to determine these two variables. So lakes and rivers now, some important points on lakes and rivers as a component of the water cycles, but also proxies of climate change. On the top left, you have an image which represents the GRDC, which is a global runoff data center, which gather in situ data of river discharge worldwide, but it is very inhomogeneous and also not perennial, with a lot of gaps, etc., etc. So it's difficult to have a full overview, a global view of the discharge on the world. But the problem is that rivers, they supply water to the ocean. As I said, they contribute to global sea level rise. They also transport sediment. They interact with the regional environment through the inundation, drought, irrigation, navigation, water consumption. So for all of these reasons, discharge is a key variable which allows determining the role of the river in the water cycle and the water use. That's why it's very important to calculate river discharge. And for lakes, they are considered as integrator, which means that they are some kind of archive of the climate, regulator, because presence of lakes regulate the regional and the global climate, and also sentinel, or we say sentinel or proxies or indicators, as you want, of the climate change. Their role in greenhouse gas emission is also not well known, which is another important point. The volume of lake is the key variable which integrates all the change of the different components of the water balance. So that's why with SWOT we are trying to prove that the most important point is to determine the volume of lakes, because this is the key variable. So also another point which we have to remind is that a lake is never in equilibrium. The equilibrium is given by the fact that all the inflow equal to the outflow, but it's never the case. So a lake always evolves towards the equilibrium. And it's important for the water cycle, and it's important in order to determine this water balance to have the volume change of lakes. So they contribute to the water storage, to the water cycle, through the storage, to the outflow and inflow. So the role of lake is crucial in the water cycle and the climate change. And in order to show that more in detail, here are two examples of studies that are very recent studies. One which on the left, which is done using satellite altimetry, satellite imagery in order to determine the total water storage viability on the Earth. It has been done on already a large number of lakes using satellite altimetry, imagery, some bathymetry, etc. And what has been shown over 40 years of data is a declining of the storage over 60% of both natural lake and reservoirs, which is enormous. It is shown on the figures, and the global natural lake volume decline at a rate of minus 26 gigaton per year. And another important result of this study is that the reservoir storage increase account for almost 20 cubic kilometer per year. So it means that it contributes to the global sea level rise, or in fact, it decreased the sea level by a very small amount, but it's important to determine that. So, but the problem is that this has been done only on already on large number of lakes, but it's only partial. We don't have anything on the small lakes on such studies. And on the right part, it's another very important paper which has been published very recently, last month, done by some Chinese colleagues, which have so what they have done is to show the role of lakes depending on their extent on the greenhouse gas emission. And I'm not detailing the results, but just one very important point is that in fact what is really to say influencing the greenhouse gas emission is the small lakes. The small lakes account for 15% of the global lake area, but they show a very high long-term temporal variability, and also they contribute a lot. They are the most contributor. You see 37% for the methane and 25% for the CO2. So what does it mean here is that monitoring small lakes, it depends on the extent of lakes in particular. Monitoring small lakes is also very important in order to determine the balance of the CO2 and methane in the atmosphere. So that's why also SWOT will give an important input to this kind of study, because with SWOT we will have the water extent of lakes of very small lakes, not only the big lakes. That's 2 points to show the importance. So SWOT measurements and products. So SWOT is an interferometer in Ka band. It will measure height, extent, and volume change on lakes larger than 250 by 250 meters. It represents almost 1.8 million of lakes in the world. So most of these lakes are small and not observed actually from ground or from satellite. So just remind what I've said just in the slide before. It is very important in, for example, in the greenhouse gas emission. They will allow calculating the water storage change. This will allow calculating water storage change, SWOT, and also understanding the role of lake in water cycle, but also in climate. The river now, we will measure height, slope, and width of the river larger than 100 meters. This will allow calculating discharge along predefined reach, or which is some kind of parts of rivers of 10 kilometers. This will allow understanding the role of river in water cycle and on sea level changes. And this will also allow understanding the interaction with floodplain and groundwater dynamic at basin scale. It is an important point which is not so well known today. The SWOT measurement will be released every 21 days, and every passes on shape or vector file with every passes shape of vector files, pixel cloud, and rasters. So we have 2 SWOTs of 50 kilometers on each side of the nadir on which we will get this measurement. So this is a very new instrument, never sent before. So how does it work? So this is a slide which shows the principle of the SWOT measurement. In fact, it's based on interferometry, as I said. So we have 2 antennas. One is emitting and the 2 antennas are receiving the signal. And we measure the distance between the lake surface or the river surface and the antenna. And we will measure also the phase differences between the 2 signals received by the 2 antennas. So this, I'm not detailing the equation. It is quite simple, but the water height is determined using the distance of the first recepted signal and the view angle of the signal. The width of the river and the lake extent are measured using mapping water pixel deduced from radiometric contrast. So this is the principle of SWOT. And so knowing this interferometric phase, we will determine the height of the water surface every on pixel of 70 meters by 10 meters in average. So that's the point for SWOT. So what we will measure now with SWOT in terms for the lakes, you have a maps here of North America, which is covered by millions of lakes in reality. So of course, none of them are, or not none of them, but most of them are not monitored today using in situ. So SWOT is required to observe lakes larger than 200 by 250 by 250 meters, as I said before. So recent work by Youngwei Chen at UCLA suggests that these are 1.8 million such lakes worldwide, and we have the repartition of these lakes by continents, and which shows, in fact, is on the top right, which shows, in fact, that which is quite trivial, but the highest number of lakes are small lakes, as you see in Asia, North America, etc., etc. So most of these lakes are small. Almost none of them are currently observed on the ground or by satellite altimeter. So that's why SWOT will, in fact, make a kind of gap filling in terms of extent worldwide, so which has not been done before. So how we will measure lake volume from SWOT? So SWOT will not measure volume directly. SWOT will measure extent and will measure height of lake. So, but by combination of extent and height, using this equation on the top right, we can determine the volume. So what we have done until now is a lot of simulation in different projects in order to investigate the errors that we expect to have using SWOT in different situations. So we have simulated a lot of different case studies using real bathymetry or using synthetic bathymetry in order to see what are the errors. And we have implemented the algorithm proposed here. So simulation were done on some dozens of lakes in different sizes and shapes. And what we have observed, and it's important to remind that, is that the errors has never exceed 10% of the real volume change. This is just here an example. So we produce pixel cloud, we produce height, so using simulators, and we calculate the volume and compare to the real volume that we have simulated. So that's an important point. So the most thing to remind here is that if we have water height, water extent at the good with a good precision, as we expect with SWOT, then volume will be deduced very easily and quite accurately. For the river product now. So here is a database which has been set up by American colleagues, which is the database on the global reaches on which we will calculate the river discharge. So height and width on nodes every 200 meters along the river central line will be provided. Average 8 slope discharge over each reach. So this is a reach of 10 kilometers on the river. So this is an a priori database, will be also determined. So this is a kind of illustration in the world on which SWOT will produce river discharge. You can see that it is enormous. This is an enormous amount of river reaches. We have more than 100,000 rivers reaches. So now, as I said, SWOT will not measure directly the discharge. It will measure height, slope, and width of the river. So how are we going to determine the discharge using the SWOT data? Two approaches were elaborated and tested by the science team. Basically, we consider two approaches that are the hydraulic and hydrologic. Hydraulic one is a direct estimation of the discharge along the reaches from inversion of the Manning equation. I will show that just after. And hydrologic approach is to consider the SWOT data, water surface elevation and discharge, assimilate this data in global model using SWOT. So the validation of those approach we are doing using large scale and high resolution simulators developed at CNES and GPL. So this work that I will just show some example represent almost 10 years of research and development from several teams in France, in United States, in Brazil, in different countries. So there is the hydraulic approach. So on the top left, you have the so-called Manning equation, on which we have, in fact, three unknown, the friction, so which is represented by N here, or the Strickler coefficient, the bathymetry of the lake, which is represented by the A, and the discharge, which is represented by Q. So it is an equation which is solved only through inverse method, and it cannot be directly determined. So the many models have been tested over a set of several rivers within the SWOT science team. And generally, the flow model are combined to variational data assimilation, and it shows excellent results in determining Q, N, and A. So in fact, the point is to make some iterations, so to determine, to make some a priori on the bathymetry, for example, to inverse and to recalculate. And you have some example here on the simulation which has been done on different rivers by different groups. And we have the truth and what is estimated. And you can see that with this different method, there is a good expectation to determine quite precisely the discharge of the rivers. So that's the first point. The second point is assimilation of data in models. So the idea is to have a better understanding of the global hydrological cycle. The objective is to assimilate SWOT river products, elevation change, and discharge determined by hydraulic inversion, in routing model like CTRIP at high resolution, and of fluxes model. So this is an example of work done in France, but you have the same done in other parts of the world. So this is just an example. And what has been tested here is the performances of the discharge assimilation on the test case, which is the Congo Basin. So the relationship between the water elevation and the river discharge in CTRIP may be very different from what SWOT will observe. So we have a priori information, but we consider that SWOT will provide some differences on that. And what has been assimilated here, and the main conclusion is on the left part, the image on the left part is we have considered water surface elevation with an error of approximately 10 centimeters. And on the right part, the discharge with an uncertainty of 40% has been assimilated in the model. When you have the blue color so this is the Congo Basin, as you can see. When you have the blue color, it means that the discharge assimilated is better than what can be done using simply the model. So you can see that on such big basin, without any in situ measurement, in fact, there are very, very little number of in situ measurement in order to check the discharge result. We can see that using assimilation of SWOT, water surface elevation and discharge, improves a lot the outputs. So that's what has been shown by Météo France and a different laboratory in France on Congo Basin, but it has been shown also with on other groups. So the ongoing work is to have a more realistic stage discharge relationship, high resolution simulation with more complex river geometry and process using, for example, the least fluid model. And work is also going on to try to understand the sensitivity of the model to different parameters and to also include the lake model in this global hydrological model. Now, some word on the hydrology Calvary. So Calvary is a very important point when we are doing such, when we are launching such satellite. Before it can be done in operational mode, we need to check and verify many things. So we have two types of approach for CalVal. We have a global CalVal, which simply consists in the comparison of the products, the water level, the water discharge, the water extent, etc., to in situ data or to other satellite data like satellite altimetry or imagery. So this is the first point. A lot of work is prepared to do this global CalVal. And we have also what we call the on-site CalVal. So which means that we have set up full operational and perennial dedicated sites. They are represented here on the map on the left, with, as you can see, many sites in South America, in North America, in Europe, etc. So we have two phases of CalVal also. We have what we call the one-day orbit, which means that the 3 first months of the mission, the satellite will be put on a specific orbit, which is not the final orbit, which is an orbit which with a repeat cycle of 1 day. It will be for 3 months after the beginning of the mission, and then we have the nominal orbit at 21 days. During the 36 months of the lifetime of the mission. So, but we will do the CalVal during these 2 phases. So the CalVal is a long-term cooperation between IRD and CNES and all of the partners worldwide, and it has allowed to cover a wide number of hydrological situations. The point here is that we are trying to cover different rivers in different regions, different lakes in altitude, in arid region, in the tropical areas, etc., in order to assess the performance of the CARIN. CARIN is a SWOT instrument from this CalVal. So there is an active participation of the science team, all the science team, and the CNES team also in this effort. All sites that are shown on this map have been equipped. Many pre-campaigns have been done, and algorithms to intercompare with the SWOT data are now coded and ready. So CalVal is an essential task before the data can be released to the science team and to the users. And as is written here, I think we are now ready for to ingest all the SWOT data through the CalVal site. So just to finish, SWOT has a short history of French and US fruitful cooperation, which has been extended to many other countries. So but important to remind also that to set up such a mission, it's very, very long effort. The first presentation of the concept of a radar interferometry mission was done in 2003 at IUGG conference in Sapporo. So the CARIN concept instrument was proposed to the 2007 US Decadal Survey, so in a French-US cooperation framework, the Earth Science and Application from Space, and so it means that it has been really officially presented 15 years ago. Many preparatory meetings were organized, science working group in different years, 2006, 8, 10, 11, that have defined the mission science requirement and the concept review. Then we had what we call the science definition team and then the science team. So many key achievements thanks to the science definition team and the science team on the payload, resolution mass, the organization of the work, the science application, etc., etc. So, and since 2016, which is important to show also, is that after the first phase, where it was mainly France, US, also a little bit Canada and UK, then it has been internationalized with a science team, in particular many new teams in South America, as you can see on the map here on the right, with many different laboratories, universities, etc. in Brazil. We have, using this science team and using this cooperation, we continue the development of algorithm, of science application, of CalVal plan, etc., etc. And so that's a very important point. And now, just to finish, so the launch of the satellites, we are very, very close. It's in December of this year for 42 months. The 3 first months are without any data for science. This is what we say the commissioning phase, where the engineer will check that every instrument works well. Then we have the 3 months of Calvary phase. So data released to the Calvary team is expected at the end of this phase. And then we have the 36 months with the science orbit. The satellite will be launched by the SpaceX launcher in Vandenberg in United States. And you have here a nice view of the satellite, which has been mounted in Cannes in south of France. And so here is the team with the satellite. You see that is a very, very big instrument. So I think I have finished and I'm ready for any questions. And I have some backup slides if necessary on the Calvary, but I think it's quite enough now.
Okay, thank you very much, Monsieur Cretaux. Really impressive work, really rich presentation. So thank you very much for your presentation. Agora, começar a parte de debate. Passo a palavra para o Daniel para tecer suas primeiras considerações e apresentar uma pergunta para o Monsieur Cretaux.
Bom dia a todos, né? Obrigado pela apresentação, pelo convite, por estar aqui, né, no Lago em Pauta da BR Hydro, né? O Jean-François fez uma apresentação incrível assim, sobre a expectativa sobre o SWOT em si. Eu acho que para toda a comunidade sul-americana de hidrologia existe uma expectativa enorme para essa missão, né? Nós do Serviço Geológico do Brasil temos essa missão de realizar o levantamento hidrológico do país e também operamos sistemas de alerta de eventos extremos, né? E um dos desafios é justamente conseguir dados em regiões de difícil acesso, né? Tanto como a Amazônia e também regiões como a Amazônia, que são regiões de fronteira, né? Que são regiões que a gente partilha a bacia com outros países, né? Então o SWOT ele vem também para ajudar bastante nesse desafio, principalmente em regiões como o Pantanal, a bacia amazônica em si, que tem diversas planícies de inundação, né? Pelo nosso monitoramento, a gente é ainda limitado por medições pontuais de réguas e pontos de acesso, e o SWOT ele vai trazer essa cobertura em toda a bacia, né? Então a gente vai conseguir densificar muito a informação hidrológica, a gente vai conseguir ter uma ideia, como o Jean-François apresentou, do estoque de água nas diversas planícies de inundação, nas diversas lagos e várzeas dessas bacias. Com certeza isso vai ajudar muito na prevenção, na previsão, né, de eventos extremos, né? Como a gente tem ocorrido nesse ano com uma cheia extrema e uma seca extrema também na bacia amazônica, né? E como a gente vem sofrendo ao longo dos últimos anos também no Pantanal, né, com escassez hídrica, né? Então, só tenho a agradecer essa apresentação em si. E uma questão importante também, né, como o Jean-François falou, também esses dados vão ser gratuitos, né, eles vão ser dados livres e abertos para a comunidade científica. Mas gostaria de encerrar por aqui fazendo meu agradecimento. Não tenho muitas perguntas para o Jean-François, só realmente assim que eu estou bastante animado com o lançamento do SWOT, né? Expectativa enorme para toda a comunidade de hidrologia.
Legal, Daniel. Realmente fica na expectativa. Agora eu passo a palavra para o Fabrício, para ter suas considerações, se tem alguma pergunta.
So Jean-François, thank you very much for this very clear and excellent presentation about the importance of SWOT regarding the water cycle. So I would just have one question regarding, like, you know, what we call the future of hydrology from space. We are entering now the phase where we have all the technical development, and we are now entering what we call operational hydrology, which is the way of monitoring constantly, almost on the real time, the state of rivers and lakes and wetland. So if you could say a few words from that, because you also have the experience of this development through the year over the ocean, then we expect to reach this kind of maturity. So maybe that's nice to introduce everyone what is hydrology from space in an operational context, because linked to the conference, we will have many operational agencies from Brazil and other countries, and I think they would be very interested in hearing from this. Just a few words, and then I will present the context of the conference after that, and the program of the upcoming one.
Okay. Yes, of course, you are right. This is so SWOT is an experimental mission. We try to develop the concept and to show that the concept is very, interferometry is very keen to determine essential variables for hydrologies, for in science, but also in operational. Of course, SWOT lifetime is only 4 years, but thanks to all the developments that has been done, and thanks to also the fact that we have also already many operational systems like the Sentinel missions, we of course it is only the beginning of the story, SWOT, and we expect a lot. But the preparation of the future operational system is already on the road. You know, maybe that European Space Agency is preparing the future. So we have the Sentinel, and we have the new generation. And from what I know, what I learned very recently, ESA already decided to develop in the future a kind of SWOT constellation, so not the same instrument with a large baseline, etc., but for operational services. So yes, this is the very, very important following of SWOT, but SWOT is in the continuity of what exists already in satellite altimetry. We have already an operational system, but not so global. So the future, clearly, so we hope that SWOT will demonstrate that it is the way to where to go, but the decision has been done already somehow. Of course, we will not have SWOT follow on right now, but the same kind of concept will be put in orbit very in the next year with ESA. And I'm sure that I talk about ESA, but I'm sure that NASA is also already thinking about a SWOT following, and always, no, it's not for experimental design, it's really for operational. So it's the main point for the future is, you're right, is the operational system. And I'm very confident and very, I'm very confident that the future system will allow to enter in a real operational monitoring to mission like SWOT and others. SWOT is for water surface, but you have also many other things on precipitations, on the soil moisture, on the snow, etc. It's only one component, but for all the components, you have operational system now.
Okay. Very good, thank you. So this is in this context, I believe that we can now introduce the series of conferences that we are organizing, and for which the next one will take place in a few weeks from now. So quickly, I will share my screen. And I will introduce quickly to all the South American Water from Space Conference, and mainly the context and objective of these conferences. So the primary idea in the context of SWOT and also operational hydrology started about in 2015, where a group of researchers started to think about gathering scientists from South America, which were mainly interested in hydrology from space, and more specifically in the future SWOT mission. So all this started with a kickoff meeting that took place in 2015 in Rio de Janeiro at the headquarters of CPRM, the Geological Survey of Brazil now, which is a historical partner of all the French laboratories that work on hydrology from space, especially Lagos. So from this first meeting, there were major outcomes that comes and that we call SWOT early adopters from South America. So gathering the people to be adopters of the SWOT mission. So this came out with a selection of several projects for the science team of SWOT for the year 2016 and 2019. There was an agreement of a MOU that was signed between the IRD and CPRM that support the field work on Brazilian rivers. The launch of an international group of work from IRD, which was multi-country and devoted to the Calvary of SWOT that Jean-Francois introduces. So it was a multi-country project between France, South America, Africa, and India. So all this in the science part, there was more than 60 publications now that were co-signed between scientists from France and South America on this related project. And now we are in the phase for, since 2020, there is a lead project, which is called SWOT for South America, which is part of the science team of SWOT. And that gather again about like 20 scientists from France, the US, and South America working on these related questions. One of the main objectives of this was the preparation of the Calvary that Jean-Francois talked, and that involved many countries in South America, in particular Brazil with the CPRM, on many regions or rivers, Chile and Argentina, especially for the Andean lakes, Colombia, but also French Guiana. So it's an ongoing and pursuing efforts. There were more than now 50 field campaigns covering thousands of kilometers of river profile and many gauges that were leveled in order to work on this Calvary of SWOT. In parallel of all this activity, we initiate a new series of conferences that we call South American Water from Space, which has the objective of developing the collaboration between the academic world, in between the university and laboratories between France and South America, but also to turn the science into operational context, working with agency and policymakers that will deal with the management of water resources and introduce them the use of space technology in this. So the idea of this conference is to strengthen the working group between all this university and operational agency. But also we offer during this course like some courses and training to the new development and technical development on hydrology from space, in altimetry, and in the future use of data from SWOT. So in 2017, we made a small, again, like a conference at the CPRM headquarters, and then we started a more broader water cycle conference. The first one took place in Santiago in Chile in 2018 with more than 100 participants from many countries. That was organized by our colleague Rodrigo Abarca del Rio from the University of Concepcion. Then the second conference took place in Manaus, and it was called the South American Water from Space 2. And for 3 days, we gather like many scientists from, again, South America, France, Germany, the US, India, with an opening ceremony from the ambassador of France. And we had 6 sessions, 42 oral presentations, many posters. And we had 1 day dedicated to a field campaign on the Rio Negro, which you can see here on the picture. So pursuing the adventure, yes.
Sorry to disturb you, but I see your presentation is stuck. I don't know if Daniel Casai also seeing your presentation passing or some just some screen.
Well, I am on the last slide. Do you see?
No, I mean the first one. It's like, sorry.
You saw only the first one?
Yes.
Yes.
Okay, well, it's okay. So this year we will have South America Water from Space conference that will take place at the Itaipu premises in 2 weeks from now in Foz do Iguaçu. So you can visit the website hydrologyfromspace.org to have all the information. And again, okay, I'm gonna exit. I don't know why. Do you see the last one with the program? No, okay, well.
No. So,
Here, do you see this? No?
now yes.
Yes.
Okay.
So the full program is available now on our website. So this year is a 5-day conference with on the first morning, we will have an opening ceremony with officials from Itaipu, PTI, CPRM, IRD, CNES, the OTCA, and university, and of course the ABRH Hydro. We will have more than 50 scientific talks with keynotes from people from CNES, NASA, IRD, universities, and Mamiro Institute. More than 30 posters, mainly from students. Early adopter and operational hydrology session that will gather people from the World Meteorological Organization, NASA again, CEMADEM from Brazil, CENAMI from Peru, BGE from Brazil. And we will offer on the Wednesday mini courses by experts on SWOT, hydrological resources, altimetry, and field trip measurement. The conference will be broadcasted online on Monday, Tuesday, and Thursday. We will send the links later, and we hope you will join us. We expect in person about 200 people attendees, and we are looking forward to seeing you in a couple of weeks. Thank you.
Agora eu vou passar a palavra para o Daniel para fazer as últimas considerações dele, fazer o convite para o evento também.
Então, bom dia novamente a todos, né? Obrigado pelo Jean-François pela palestra novamente, obrigado Fabrício pela explicação do evento, né? Como o Fabrício demonstrou, um evento que vai contar com muitas instituições internacionais. Nós vamos ter uma oportunidade incrível de conhecer mais sobre a missão SWOT, sobre também outras questões no campo de hidrologia por satélites, como informações de chuva, de evapotranspiração, de outras variáveis também do ciclo hidrológico. Vamos contar especialmente com os mini-cursos, né, onde vão ser apresentadas ferramentas de análise e de tratamento de dados de satélites para hidrologia, né? Então, eu gostaria de convidar a todos para participar desse evento em si. O Fabrício mostrou o site, no site pode-se ainda fazer inscrições para esse evento. Esse é um evento que é patrocinado por Itaipu, né, binacional, que vai nos hostear, né, vai nos receber na usina de Itaipu em si. Então, é uma grande... é muito especial, né? Tá num lugar tão importante para a hidrologia e tá recebendo essas informações também, né? E o evento também é organizado pelo RD, pelo Serviço Geológico do Brasil, pelo CNES, pela ABR Hidro e pelo IPH, né? E um evento que tem também o suporte da própria missão SWOT, né? Do Laboratório Legos e do PTI, né? Que está cedendo espaço para a gente poder realizar esse evento. Então, convido a todos, eu acho que é uma oportunidade incrível de conhecer. Se você não tiver condição de ir em Foz do Iguaçu, como o Fabrício mesmo falou, o evento ele vai ser transmitido online nas suas principais apresentações, né? Então, espero vocês lá ou virtualmente. Um abraço a todos e bom dia.
Obrigado, Daniel. Now, I don't know if you have some last words, Jean-François.
Some last word. I'm very impatient to arrive to Foz do Iguaçu, very impatient to participate to this conference, and of course very impatient to see the satellite launch in about 1 month. So that's my word, and I will be very happy to see again all the Brazilian colleagues, also American colleagues, because we have so long cooperation, so long work together. Many of them became very close friends, not only colleagues. So it's always a very a lot of enjoying to be among you, and I'm for that also. That's my word. And thank you also, Daniel K, sorry, for organizing these small events all together. And of course, for organizing the meeting in Foz de Iguaçu. And of course, thanks to Fabrice for all work done for that. That's my words.
Thank you, Jean-Francois.
Thank you, Jean-Francois. Thank you very much for being with us and for being present here in Foz do Iguaçu. That will be an honor to meet you finally, personally. Thank you very much. Bom, eu vou fazer minhas últimas palavras, destacando esse aspecto que o Fabrice e o Jean-François mencionaram, que é a parte da hidrologia operacional. A gente vê um direcionamento da hidrologia para receber esses dados de satélite, as missões de satélites observacionais sendo cada vez mais evoluindo essas missões, ver que a ciência realmente está tentando buscar ter melhores dados e incluir esses melhores dados nos modelos hidrológicos. E eu trabalho na área de previsão de vazões aqui da Itaipu Binacional. E uma hidrologia com mais informações, ela com certeza vai ser melhor para fornecer melhores informações na tomada de decisão aqui das usinas hidrelétricas, como o caso de Itaipu. Então, esse link, né, esse pensamento na hidrologia operacional, com certeza vai estar sempre subsidiando as agências operacionais de melhor informação para suas tomadas de decisão. Convido a todos que nos acompanharam aqui nesse Água em Pauta para estarem também presentes aqui em Foz do Iguaçu, dia 21 a 25 de novembro. Estaremos muito felizes de receber vocês aqui em Itaipu. Obrigado.